Welcome back to our series on probability theory. I'm Mark Ledbetter. This is lecture video 34, part B. We're discussing bivariate discrete distributions. So last time we talked about the joint PMF and marginal PMFs, and we also talked about, we started talking about independence, x independent of y. We did the definition, f of x times f of y equal to f of the joint, f of xy. Then x and y are independent. I've already got that written, so we'll just leave it. Okay, so that's the definition. And we'll talk about the mean invariance today and the trinomial and multinomial next time, I believe. All right, so this example we looked at last time, and I was telling you at the end of the last video how I could look at this, this joint PMF, and I could easily break this up into x4 and y there and 9. And so I can break this up into two functions, one of just x, one of just y, that are not the marginal PMF. So here's some function of x, and here's some function of y. I'll call it g of x and g of y. And they, when I multiply them, they become the PMF, the joint PMF, and that the space of this was rectangular. And so I was going to tell you about some remarks and then realized I didn't have that slide in my presentation. So that's what we're picking up here. So here are some remarks, and the remarks, what's the purpose of these? This is to make it easier for us to determine whether we have dependence or independence. And we do not, that's the key part, we do not have to find the marginal distributions to do it. So if the joint support, range or space, of x and y is not a rectangle, then x and y are dependent. So if this wasn't rectangular, I wouldn't have to do anything else. I could just say, oh, no, they're not independent. However, just looking at this by itself doesn't tell me that they are independent. It has to be a rectangle or they can't be independent, but being a rectangle does not mean that they are independent. They could be independent. So I hope you'll get the difference between those two. Now, this second remark says that if the joint space is a rectangle, and these both have to be true, you can write the joint PMF as a product of two functions. One's only on x, the other's only on y, like we just did here. These are not the marginal PMFs, but they are two functions, one g of x, this one g of y. If I can do that and I have a rectangular support for x and y, then guess what? They are dependent, okay? And I didn't have to go through the calculations to find the marginals. So that's the purpose of those remarks. Now let's look at expectation. So this is discrete. X and y are two random variables with joint PMFs, f of x1, missed the 1, and x2 on the space S. We're going to let u be a function of these two random variables, and if the expectation exists, this is the definition. So E of u of x1, x2 is the sum across x1 and the sum across x2 of u, f of x1 and x2. Okay? So the regular definition of expectation, remember in the univariate it was the sum of x, f of x. Now it's, I had u. So u of x, f of x was the expectation of u of x. Now I have u of x, e of u of x1, x2. You take the u times the f, and so it's the same form. So in order for it to exist, this quantity has to converge and be finite, okay? If it's not finite, it doesn't converge, so that's a little redundant, but that's okay. So I'm going to let y be equal to this function u of x1 and x2. Then y is also a random variable, and let's say it has a PMF g of y on the space S. Then this expectation of u of x1, x2 times for u of x1, x2, which is u of x1, x2 times f of x1, x2 summed across the space, is equal to the expectation of y, which is y times g of y summed across the space of y, s of y. Okay. So let's look at the mean. I'm going to simplify this. This may look confusing to you at first, but let's say that this function of u, of u1, of x1, x2, simplifies x1 and x2 to just either x1 or x2, so xi, 1 or 2, right? Then the expectation of u1 is equal to e of xi, which is mu of I, which is the mean of xi. And again, it could be x1 or x2 in this case. We only have those two possibilities. And then same thing for u2, but now instead of being xi, it's xi minus mu I squared. Then the expectation of u2 is e of xi minus mu I, quantity squared, which is sigma I squared, which is the variance of xi. So the marginal variance, and this is the marginal mean. Okay. So let's do a quick example. There are 8 chips in a bowl labeled with coordinates x1, x2. There are 3 of the 0, 0, 2 of the 0, 1, 2 of the 1, 0, and 1 of the 1, 1. A player randomly selects a chip and is paid the sum of the coordinates. It turns out that the joint PMF can be given by this expression here. Those x1 and x2 have to be specified, the values. So then if I want to find the expectation of x1 plus x2, then I take this function here times the PMF and I sum over the values of x1 and over the values of x2. Now, I could do this as a sum within a sum. In other words, I could take and just operate on this summation here and leave x1 just as x1 and plug in for x2. And then come back and say, well, okay, here's where x1 is 0, and here's where x1 is 1. Or I can look at the coordinates. So 0, 0, 0, 1, 1, 0, 1, 1. In this case, that's a lot faster, so that's what I did. And I plug in for x1 and x2, and then I sum up, and I get 0.75. So that's the expectation of x1 plus x2. And then I can find the expectation of x1. I'm using the joint. This is f of x1, x2, and x1, right? And I'm summing across both x1 and x2. Again, I'm going to use this method of the coordinates. So 0, 0, 0, 1, 1, 0, 1, 1. And I come up with the expectation of x1 is 3/8. And not surprisingly, I do the same for x2, and I come up with the expectation of 3/8. Because of the form, this is 3 minus both of those over 8. So it makes sense that they would both have the same expectation. I can check that, and how I check that is I first find the marginal distribution of x1. So I sum across x2, and please look at this and make sure you see that we end up with this. So I'm just summing across x2, so I plug in x2 equals 0 here, and x2 equals 1 here. I add those, and I combine it, and I have x1 left, so I specify x1. And then I look at e of x1, and I say, well, that's the sum of x1 times f of x1. I do that, and I come up with 3/8, the same answer. You can do the same thing for x2. So don't forget to scan and upload your lecture notes before midnight of the date listed on the course calendar. Update your formulas, facts, or whatever sheets that you're using for this information. If you have questions, come to virtual office hours. If you can't do that, email me, but you need to send me a picture of both the problem and your work so I can solve that quickly and help you quickly through email. So please be safe, and we will see you next time.